Thanks for joining us on TVUCC, and we are currently at the Science Quadrangle where we are celebrating our efforts to celebrate the International Day of Light. The department or the School of Physical Sciences is holding a seminar and a webinar, and as part of it they're also having a fair here, as you can see right behind me. We are going to move to the various stands. There's a lab set up inside. We are going to have more information as to what goes on in there and all that pertaining to the celebration of the International Day of Light. My name is Onesifero Sobobi. You're welcome to TVUCC. Let's get inside and have an observation of what goes on. Stay tuned. So we are inside the Laser and Fiber Optics Center lab, where I have with me Dr. Peter Osei Owusu and Mr. Andy Lezote also with me. They're going to give us a rundown of what goes on. Just behind me there's a setup. It's not my field, that's their specialty. So they're going to run us through the various setup, what is to be achieved at the end of the day. And remember to always stick to TVUCC. Log on to YouTube, search for TVUCC Set Panel, subscribe and hit the notification button so that anytime we bring out these videos you get the opportunity to watch us live. So Doc, run us through the process and what we see over here.
Thank you very much. As the presenter actually said, this is the Laser and Fiber Optics Center. It's the only center in the whole of West Africa that deals with lasers and optics. So basically, we've set up a lot of optical experiments that we are exhibiting to the secondary school students and senior high school students. And at this juncture, I'll give the opportunity to my fellow colleague, who is a PhD student, to run through the setup.
Okay, so this is the biophotonics platform. Okay, this is a biophotonics platform, and it is made up of Legos. The idea is that Legos are play materials which are less expensive as compared to normal optical systems. Besides, they are of less weight, and so not very heavy as compared to the normal optical systems. And for that reason, using them to set up our optical experiments makes it cost effective. In this experiment, we use the system to demonstrate the principle of transmission, polarization, and then reflection. And how is this done? Over here we have a light source, and then we have a sample, and then we also have a detecting system, so that depending on where the light source is positioned, we can be able to observe the transmission of the light in the camera or the detector, and then also we can observe the reflection too as well. And this information can enable us to observe behavior of different substances. For instance, in this case, we are looking at an insect, and a system of this sort has been used to differentiate between male and then female mosquitoes, where we are able to know the reflections of light from the male mosquitoes and the reflection of light from the female mosquitoes to help control malaria in the environment. It can be used for bigger insects like grasshopper and other ones too as well, to help control diseases in the world.
All right, thank you very much. So you heard from Mr. Andrew Uzome. You heard from Mr. Andrew Uzome, and he has given Uzote, thank you, and he has given us an insight as to the entire setup and other safety precaution measures. We have some students here with us, and I hope you permit me some few interactions with them. I have some students from St. Augustine Senior High School and then Infantipim Senior High School. What's your name and then your school and your class?
My name is Kwabena Chisapon. I'm from St. Augustine's College, and I'm in 3 Science 2.
Okay, Kwabena Chisapon, let us have an insight as to what you've observed right now and how that will also aid in your preparations as a student. I know OASIS is just a few months away.
Okay, I learned that the materials here, it's made of a durable material. They are Lego, so anytime you are working, the setup should be at your waist level, and also even if a material falls down, you should make sure that you put the setup off before you take that object. And you also said that the eye is the window of the eye, so the window of the body. So anytime you are doing any experiment, you should make sure that your eye is not in direct contact with the laser, and the place should always be covered with curtains, else the light will affect the experiment setup. Yeah.
So after talking to one man in green, let me also deal with the red and black striped gentleman. Your name?
Inshallah.
Class?
3S8.
Okay, inshallah. First of all, let me just have your impression of today, the international celebration of Day of Light, and then what you've learned so far when you came here.
Okay, I would say this is a very laudable holiday, should I, if I have to put it that way. But yes, light is something that's very crucial in our lives as human beings, and it's very good to have a practical insight into these things. Normally we learn these things in our classrooms, but it's not too practical. So on days like these, we're able to come here. All the setups that we keep seeing in our textbooks, right now we see them physically, and it's very, very interesting to see how all the things that we've been reading about is actually practicalized and can really, really help us in applying them wherever we find ourselves. So yes, today is a very, very interesting day. It has been a very interesting day for me.
All right, thanks to you. So we'll move to the next lab setup and also find out what goes on over there. All right, so there's this huge figure. Reminds me, I mean, when it comes to film production, our lights, our cameras, and some of the things we used to shoot. But of course, this is nothing near the things I'm talking about. This is the remote sensing telescope, and I still have with me Dr. Peter Osei to do the discussions with helpers and assistants on these, and of course some resource personnel will be giving us more explanations how it works, what it is used for, and even if it can be bought and used for domestic activities. It's going to give us answers to all these things. Doc.
Okay, thank you very much. As my presenter rightly said, this is a remote sensing telescope, which is currently at the Laser and Fiber Optics Center, UCC. As I've said earlier on, the center is the only center in the whole of West Africa, the only center in Ghana that deals with light and light-based technology in Ghana here. So this telescope you see here is the only one you can find in Ghana here, and we have 5 of them in the whole of West Africa. 5 countries actually have this telescope. So this telescope is actually for remote sensing, and then it's been applied in entomology, that's environmental science, pollution, and then being applied in water quality research, environmental research, and any agricultural research to remotely sense information from a far distance object. So basically, as he was talking about, the telescope here is being used in so many ways. This side of the telescope, that is the sky watcher, but it's being used as to collect information. So this side, as I said, it's a laser spectroscopic technique where we use this part of the telescope to send laser. So a laser is put over here, and then this laser is sent to a far distance object. So the target is a mango. The laser is put here, and then it's being targeted on the mango. So the laser now interacts with the mango, or interact with the object, and then the backscatter light is being collected by this part of the telescope. So if you look at it critically, in there's a mirror. In the back part is a mirror. That's when the backscatter light is being collected by the mirror, and this mirror reflects the light to another mirror here, which they also reflect the light to this part. So a detector is put here that detects the light, or that detects the signal. So whatever signal is being detected by the mirror is being detected over here. So either you put your eye or you put a camera here. It's okay. So since you are dealing with lasers, putting your eye here, you're going to damage your eye. So you put a camera in here to detect the signal. So either you put a camera as a detector, or you use a spectrometer to detect the signal over here. So basically, as I said earlier on, you send your laser on to a far distance object, then get the information. So, for example, if there's information that you want from a tree remotely, you just send the laser there. By aligning the laser well, then the information will be sent back to you through this part of the mirror, and then you detect it at that side of the mirror. So basically, that's what we use it for. So the other side of the telescope is used to actually look for your target. So use the telescope to actually gauge and then align your object, your target, so that you can actually work on it. So that's what, in the summary, that's what you use this telescope, remote sensing telescope for.
What's the name of this part and what does it do?
Yeah, this part of the thing is also the telescope aspect of it. So we also look at it, also using aligning the object. It's not okay. It's not coming. Yeah, so it's also used in aligning the object. It's not okay. So if you're aligning, so in spectroscopy, alignment is very, very key. So before you are able to get the information back to your sample, information from the sample back, you need to do a very good alignment. Other than that, you need to do very good alignment. Other than that, you will not get any information back. So that's the main reason why you have a lot of this telescope side by side, so that you can actually align your target before you can get the information back.
So this is the last setup for the day, and I'll leave it for the experts to do the talking, and they are going to hear from us.
Okay, thank you very much. This is one of the exhibits we are showing the senior high school students as well, and it's a UV transparency setup. As we already know, UV is very harmful to the eye, and long exposure of UV radiation to the eye will definitely lead to cataract formation. So basically, we've came out with a very simple setup that will be able to check whether the spectacles that we put on, the sunglasses that we put on, actually block away the UV radiation from the sun. So we came up with a very simple setup that will be able to do that. Aside that, we also know that high UV will be able to destroy the nutrient content in food. So most of the food packages that we have are transparent bottles and glasses. And how sure are we that these transparent bottles and packages are able to block away the UV radiation in order to protect the nutrient of our food? So we came up with a very simple setup that will be able to check whether our transparent bottles, transparent materials are able to block away the UV radiation. So a very simple setup, but very, very innovative. So at this juncture, I will introduce our MPhil students here, who is going to go through with you how the setup works and so on and so forth. So Mr. Rabi Boatin is an MPhil student at the Laser and Fiber Optics Center. Rabi.
Thank you. So my name is Boatin Rabi. So we have two lenses here that we are going to demonstrate here. This lens is a photochromic lens from the hospital, and this lens is a lens bought from the market. So we have a device here that's DT Mini 2GS. This, what it does is to just mimic the radiation that the sun gives us. So the radiation that we are getting from the sun, this device here is going to give us the same radiation. So from here, the light source here goes through a fiber and is exposed here. The light source right now is collected from this particular fiber, another fiber, and is given to a detector here. So this detector is a spectrometer. It's USB 4000 from Ocean Optics. And here, the photons here is going to change to a signal for us to understand the radiation that we are getting here. So from here, we can see that the signal that we are getting here, we are getting UV radiation A and B, that's from 230 to 400 here in the visible range. Because we don't need the UV radiation, we are expecting that in case we put a material here in between the light source and the detector, the UV radiation here should be cut off and the visible range should be stayed there. Okay, so we are going to demonstrate it. So this one is a lens from the hospital. So from here, we can see that all the signals we are getting from the UV radiation right now is cut off, meaning this lens is a very good lens for protecting our eyes from UV radiation, compared to a lens bought from the market. So from here, we can see that there's a signal that the detector is reading. That's from the UV radiation, meaning the lenses that you use in the market is not UV protected, and in as much as the aim of buying the lens is to protect our eyes, you are not getting that aim. So we should be very mindful the type of lenses that we are using, and the lenses that you buy too, you can bring it for us to check whether it's UV protective or it's not UV protective. Thank you. So we can give you yours. So one student is using a lens here. We can come and put it here. We want to test his lens if it's UV protective or not. Okay, so the line here is showing between the UV protective and the visible range, and we can see a signal here, meaning a lens that is using is not UV protective, and it should be changed or corrected. Thank you very much.
Why in a hurry to say thank you? We are going to ask you questions.
So, looking at the experiment you've just carried out, should we be scared, especially for some of us who love to use these ones as compared to the ones provided at the hospital?
Yeah. We should be very mindful about the lenses that we buy, especially we have a perception about the lenses that we use. Probably people think that the ones with the tinted and darker ones protect UV. We should be very mindful. You have to go to the hospital, explain your issue to them. They should give you a very medicated lens. That's a photochromic lens. This one is not magnified. The main aim of this lens is to just protect your eyes from what? UV radiations. So we should be very mindful from the lenses that you buy from the market. Or probably you buy a lens from the market, but you bring it to the lab here. You check for whether it's UV protected or it's not UV protected. That's the most rightful way. Thank you very much.
All right, so you've heard from them. We've learnt a lot here. So if you want to protect your eyes, of course, I look good in them, but in reality, I'm not really protecting my eyes. And that's how we end our coverage of this year's International Day of the Celebration of Light here on the campus of the University of Cape Coast. Of course, the laser and fiber optic department has shown us a lot. We've seen a lot of things. You talk of the fiber optics. We've seen a lot of setups, and we've also seen how we can also protect ourselves from lasers and all that. My name is Onisifero Sobobi. Remember to always subscribe to TV UCC. Just go on YouTube, type TV UCC. It's one word. You get it, you subscribe, and you hit the notification button that anytime we upload a new video, you get the opportunity to also watch. Of course, follow us on Twitter and then on Facebook as well. Catch you next time, and I think with the next celebration, we'll be at your homes. Stay tuned.